Hello everyone in Graphical Python Programming, CSC-121. We are continuing in the last module of the class, and you should have, and I really say you must have, watched the first video that was the long one, Introduction to Threading and Multiprocessing, where you saw a bunch of these diagrams so that you understand what it is that we're actually trying to do here. So in that introductory video, I showed you using Python's threading library how to create a threaded program. Now, we also mentioned in that video that Qt, the PyQt5 library that we've been using, implements its own GUI event loop, and that each thread then becomes part of that event loop. So using the Python threading library as is tried to be done in the textbook does not work well, because you're taking basically something that was written for Python that doesn't take into consideration the GUI Qt event loop. So you're much better off, if you're using Qt, to use the Qt approaches to threading, which there are two. The first one that we're doing in this video is doing the QThreadPool approach. The ThreadPool approach works well if you need to just send some threads off to do some work, and you don't have to get much of anything back from them. You can just kind of, one of those fire and forget type things where you send it off to do this work, and you can wait for it to get done, but you don't need any kind of connection to any signals or slots, because you can't really do that with the ThreadPool approach. So that's a disadvantage of using the QThreadPool approach, is that it's kind of fire and forget. Some of the advantages are it automatically adjusts itself to the number of processes that it has out there. So it will look at what's available on the computer and figure out how many times it can thread that thing out. It'll also, it's just a simpler approach. So let's get started with the ThreadPool approach, and that is the approach that was being used in the little demo program, and that's what we're creating right now. So I've already created the UI, and at this point in the class you should be able to create a UI like this. There's nothing special about the UI. It has some push buttons, okay, and I created this UI using the GUI template. So it's got a push button to start the for loop that populates this list box. It's got this list box here, this list widget, and it's got a button to do the no threading approach, and it's got a button to do the threading approach. And that's pretty much it. Nothing special. As I said, a list widget and then just some push buttons. So no real earth-shattering things in the Qt designer at all. Okay, so let's open up this GUI template with not with the text editor, but with Tawny, and we'll get cranking with that. So this is going to be our QThreadPool demo, and we'll want to import or have our UI file come in here, and our UI file is QThreadDemoPool. I need to change that name so that it matches in my Qt program. So this is going to be QThreadDemoPool.ui, QThreadDemoPool.ui. That's what we're bringing in. That's our UI file. And so that I'm saving this as the same name, I'll just copy that, and I'll go up here and do a file, save as, and get to the right folder here. Got a long way to go here with this finding this folder. Looking for the RCCC folder, and then 2020 spring, and then module 7, and then QThreadPool lecture. And so that's what where we're gonna save this, and it'll be .py, and I'll save it. And so that should be named the same now as our UI file, and it is. You can see the two files out there. So this is the UI, this is the Python file. Okay, so in order to make this work, we will need to first let's test this and make sure that everything's working the way it's supposed to. And it is. So we've got that much of the program working, just don't have anything hooked to these buttons, as you can see. The only button that's active is as an exit button. So nothing special there. So let's go ahead and add some imports here. So import time so that we can see how long it's taken to run this stuff. And then I'm going to import a special library that makes our rolling through lists and things much easier. itertools. That's got a special function in there that we can use if we have two lists and we want to roll through those lists like we were doing with a for loop to roll through every element in the list without having to use an index. So there's a special method in here that's the zip method that lets us roll through things. Nice little method. So we're going to also need to import some other stuff here from Qt Core. So I'll copy that and paste it down here. And so some of the things that we're going to need QThreadPool, and we're going to need QRunnable. So ThreadPool is what's going to let us send things out to be run, and QRunnable is what we're going to use to create our objects for our threads. And lastly, I don't think we'll need this, but there's a QThread in case we do need it. I'll go ahead and put it out there. So I think that's all that we need. So first off, I know in the demonstration that I showed you using the Python threading how we just created a function, but I want to talk to you about why that's a bad idea when you're threading stuff. When you're threading things, you can have multiple instances of that thread running the same code. Now think about that for a second. If you've got variables in there, you don't know which thread is operating with those variables at any given time. So a much better approach to almost everything when you're threading or whether you're multiprocessing is to use an object. And way back at the start of the class in module 1, we created objects, and we have been using objects all the way through the class. Every form that we create for a Qt program was an object. So in order to create something to run, I'm going to create an object for our threads, and that way we can be assured each time we create a new thread, it's a new instance of that object or that class. And so that means that those classes each have their own variables, and we don't have to worry about one class touching another class. Each one is its own independent set of code. So class is the way we start creating an object, and I'll call this a task. Okay, and it's going to inherit QRunnable. If you're going to use the thread pool in Qt, you have to inherit the QRunnable. So it gets everything. This class that we're creating is going to get everything that's already been defined for the runnable class. And now you don't have to have a constructor if you're inheriting this, but I've got some things that I want to do in my constructor, and if you do want to pass some things to this, then you're going to need a constructor. So self and thread number and delay. So those are what the parameters that I'm gonna pass to this thing. Okay, and then I want to go ahead and run the constructor for QRunnable. That would happen automatically, but since I'm implementing my own constructor here, I need to go ahead and put a super call in there to run it. And this is the only time that you don't pass self to something. So I'm saving the thread number that is coming in when we create an instance of this class. I'm saving the parameter thread number into a variable called thread number, and because I put those two underscores at the front of it, that means that this is a private variable that folks normally don't get to outside of the class. Okay, so this right here is going to get shoved into this private class variable that we can share with every method of our class. And then the other, I'm going to do the same thing with the delay. Okay, so that's our constructor. Nothing special going on there except that I'm saving the two things that get passed to us when we create one of these. Now, this is the part that has to be there. You can't leave this off. Every thread that you create has to have a run method. That has to be there. So I'm going to go ahead and save the start time, and I don't actually need to save that as a self variable. I can just use it right here. Start time equals time.time. So we're getting the time that this particular thread started. And then I'll print that out using an F string. So using an F string here, I'll put myself a placeholder in here and say this thread and remember that variable right here. This variable is where we captured the thread number. So this is self.thread number, and we're going to save that, print that out. So that's our thread number, started sleeping for, and we'll say how long we were going to sleep. Self.delay. Okay. Seconds. And we'll put a /n on that. Okay. So close my print there. Okay, so this, when our thread is actually started to run, it's going to do this. It's going to capture the time, and then it's going to print out this message so that we know when it started and for how long it's going to sleep. And then inside that thread, we will sleep. Going to do a little delay here. Self._delay. That's how long we're going to sleep. And then this is an important thing when you're threading, and you've seen me put this in there before. Q application.process events. This lets Qt go do things. There's another method that we haven't used up to this point in the class, but sometimes it's actually better if there's some things that are going on in the background. And so I'm going to use it just so you can see how it works. Send posted events. Okay. Q application, send posted events. And this one is a lot of times is a better choice when you're doing threading. Duration equals time.time. So we're getting the time again right there in the duration. And then when we finish, we'll print our F string out again. We'll use an F string. Thread number. And we can actually copy that from up here. There's our little using that thread number that was passed to us so that we know which one we're talking about. Finished in. And then we'll put another placeholder in here to print out duration. You see how much nicer that is than doing old style string formatting. Okay, and I'll do another /n. So we've got those two F strings. That's our run method. So we've got a task here, and that's set up where we can now do something and run it. So let's go ahead and connect up our push buttons and see how those work. So we've done this before, but in our main form, we've already got it importing the right UI file, and we've checked that. Push button. We've got several push buttons to hook up here. Push button, run no threading, clicked dot connect, and we'll connect that to self dot run no threading method. Okay, so we can go ahead and write the run no threading method down here. This is just doing run no threading method. Okay, make sure I spelled that right. Run no threading method. Yep. Okay, so this will just run this. We'll create an instance of a couple tasks out here, and we'll run them one after the other. So let's get that working first, and then we'll come back and actually run these with threads instead of just one after the other. So self dot start time equals time dot time. Okay. Jobs equals, we'll create a list called jobs. We'll create a list with our task IDs. Task IDs equals, I'll go ahead and capitalize the IDs there. Okay. We'll create a list of those. 1, 2, 3, 4, 5, 6, 7. Got those. And then delays, how long we want each of those to delay. And we will reverse that list. How's that? So the first one is going to run for 7, 6, 5, 4, 3, 2, 1. Okay. So that's our to list, and you remember we imported that iter tools at the top so we can do some fancy stuff with our for loop now. Task and delay. These are two variables that we're creating right here. Each time we go through this loop, you'll see I'm using the zip function that I told you about at the start. Each time through this loop, we can get one of the task IDs, and the other is the delays. Okay, so let's talk about what this is doing right here. Each time through this for loop, our variable task is going to get one of these numbers, a new number from that list task IDs. Each time through this loop, each time this loop cycles, we're going to delay is going to get one of the delays. Okay, so they're synced up, aren't they? First time through the loop, task will have 1 in it from here. First time through the loop, delay will have a 7 in it. And so that's going to let us run these jobs. I'm adding an element to this jobs list for each job that I'm running out there. And so I'm creating an object and adding it to the list each time through this loop. And so the object that we were creating was coming from the a task. That's that object that we created up at the top of our program. Up here, we're creating one of these. Okay? And so right here, what goes inside these parentheses are the things that I was saving in the constructor. Thread number and delay. Okay? So that's what we're going to pass to it. Task ID. Or excuse me, no, we just called it task. And right here is where I'm getting that from. And the other one is delay. Okay? So that's going to add one of these to this jobs list that was empty up here. And we need to run it, so we'll call the run method on that. So our loop here is going to get a new task created each time through. Now, we saved the time that we started up here in self.startTime. Now we can come down here and get the time that we finished. Get the time right now and subtract the self.startTime from that. Okay? And then we'll print that out using an F string. And we'll say all 7 tasks finished in need a space in there. Okay. That's our placeholder for duration. Okay. All right, so this, again, we've got this connected to our push button run no threading. Is that what we called that push button? Let's go check. Oops. I've already got that running. Push button run no threading. Yep, that's what it was called. So push button run no threading is connected to the run no threading method. This is our run no threading method right here. We're capturing the time that it starts, creating a list to hold our jobs. We've got tasks, we've got delays. Here's our for loop to roll through our task and our delays. This is creating a new task, a new instance of our object up here each time through the for loop. This is running it and it's saving that in the jobs list. So, and then here, once these things are all done, we'll get the finish time. Let's go ahead and save this and we can run this part of it, hopefully. Okay, and it says I've got something wrong right there. QThreadPool. Let's see if we can figure out what I did wrong. I left out the import up at the top. So right here, I left out the word import. Okay. So now we'll go ahead and try running this again. Okay. So the only things that we have implemented right now is the run no threading. But we do have the objects out there. The objects right here. This button right here that we wrote should create 7 tasks. Each one's a different task, and it's going to run each one of those one after the other. And this is going to block our dialog from doing anything. We won't be able to click any buttons. Like once I've got this running, I won't be able to click the exit button until this finishes, because it's blocking our event loop right here. This thread that actually this isn't even a thread. The diagram that I'm really using right now for this is going to be the one that's a single thread like this. This is what we've got going on, where each one of those 7 threads is running one, or not threads, but 7 objects has to run one after the other after the other. So back to this, let me find my dialog right there. Let's run it. And it doesn't like something here. Oh, T-task. How did I typo T-task? It's supposed to be a task. All right, let's exit and fix that. Where did I? Yeah, right there. I typoed an A and T instead of an A. So, okay, so let's try that one more time. Clear my shell so that I don't get... Okay, thread 1 started. It's sleeping for 7 seconds. We're going to have to wait for that thread to finish. Thread 2 started, sleeping for 6 seconds. You can see we need to do some formatting on that thread so that it prints out a little bit better. It's printing out some strange times there. So need to print those times out a little bit better. So, okay, all 7 tasks finished in 28 seconds, as you can see. So, that's working the way it's supposed to, one after the other. I'll clear that, and then let me run this one more time here. And you can see it's sleeping for 7 seconds. I'm going to try to click exit. I'm clicking it, but you can see that it's not doing anything, is it? It's not letting me click the exit button. So, like I said, this is blocking this code that we've got running right here. Running those 7 objects is blocking us from doing anything. So it just finished, okay? So this time right here, let's see if we can figure out why that duration is self.startTime equals time.time duration. Everything looks good there, but it's printing out some really strange values for seconds right now. But we'll come back to that. Perhaps we can figure out why we're using time and time there, and that works fine. And we're using time and time here, and that works fine. So I suspect that it has to do with, let me go ahead and make that a, I think what we're doing is we're getting 2 times mixed up. So I'm making that a class variable so that it gets saved as a class variable. And then let's see, sleeping for self.delay seconds. Oh, I see what's going on. Thread number self.delay. Okay, and duration equals that. Okay, where my duration is right here, I was not subtracting anything. That's what was going on. So timed, okay, minus start time. Okay, that should give us some better times now. There's thread 1 started sleeping for 7 seconds, and yeah, see, finished in 7.005 seconds. So that looks better. So we'll wait for these. You can see I can't do anything. I'm clicking on exit. Nothing's happening. So we're blocked because that's all running as part of our event loop. So I couldn't get out. I couldn't do anything until that finished. So now that we've seen the wrong way, the way that most people actually do it, where they block your event loop, let's go ahead and do it the right way. So we'll connect up another button here to do this the right way. Self.ui.push button, and what was that button called? Push button run threads. So, okay, push button run threads dot clicked dot connect self dot run threads method. Okay, and let's go write that method. Def run threads method. Okay, so this is where we're going to spool up our threads, and this will not block our event loop at all. So that's going to be a nicer way of doing this. Now you can tell Qt and how many threads to run at any given time, and that's a handy method to have. If you don't do this, it will go ahead and try to figure out how many threads it's possible to run on your computer by itself, and that usually works fine. But I had a Windows virtual machine, which is the way I run Windows out there, and it only had one processor, and Qt didn't think too much of that, so it would only thread something out one time. But you can override that. So if you ever need to use this, you can override how many threads that Qt will put out there at any given time to run. And you can set it to some number, but you can just pick 9. The way I came up with 9 is I have 7 here, and then I'll have my event loop running and stuff. So I made it 9 threads, and that could run at any given time. QThread, this is supposed to be ThreadPool. Okay. Let's see, let's go ahead and do this first. Self.objs equals list. So you remember how we created a jobs list here? We're going to create a threads list here. So this is going to be a list containing our threads. Now you have to make this a class level variable, because these threads are getting spun out there. They're no longer attached to our class unless we make this a self.objects. You notice I didn't have to do that with my jobs because they were all running right here in this class. But here these things are getting spun up separate. So I need to save them somewhere. So, okay. So class level. It could blow if you don't make it a class level variable. So let's do our list of threads next. And they're the same way. threads is what I'll call it. List containing our threads. This is actually our objects created. Okay, so we've got those two, and now we can go ahead and create our, we'll just copy those. We've already got them. Okay, we've got our task IDs, we got our delays that we're assigning. Okay, same deal as before, and right here, same for loop. So we'll go ahead and copy that for loop, put it down here, and make sure it's indented right. Okay, we already talked about what this zip in itertools does for us. Let's just roll through there. So let's go ahead and spin up some threads now. Okay, self.objs.append, and we're going to create our task object. A task delay. Now you notice I'm not running them right here like I did in the no threading. I had to call that run method. Down here where I'm adding it, I'm not calling the run method. That's because we'll actually cause them to run here in a moment. Now, I need to go ahead and get my my actual object. Object equals self.objs square bracket. You remember from Code Lab that a -1 is always the last thing in the list. This is an easy way for me to always get the one that I just added right here. -1 is always the last element in the list. So I've got that. Now, that object is one of these things up here. OBJ is one of these runnable objects. Okay, so here's where we're going to actually run it right here. QThreadPool. QThreadPool global instance. That gets the global instance to the thread pool. Start OBJ. So this is what actually, when we call this start, it puts it on the thread pool, and it automatically causes this code to run. You don't have to call the run method like we did here when we were doing just an object. Down here, we started it. So at this point, it's on the thread pool, and it will run. Now, we won't have a good indication of when they finish right now, but we'll go ahead and run it so you can see what it does. So here it is. I'm going to run those threads, and you can see it kicked all of them off, and look at how fast they finished. That was a lot faster than when we did it with no threading. Remember that from the first lecture? You can see it now. But we don't really know when they all finished, and we don't know the time that it took to run them all. Okay? So let's write some code so that we can tell when all these things finished. Okay? Now, keep in mind that in order to know when they're finished, since they're all out there running, why don't we just create another task that in most systems we call this a watchdog task, and this watchdog task is what's going to sit out there and run watching for these other things to finish. So I'll call this check done, and it's going to inherit QRunnable as well. Okay, because this is going to be a runnable. This one I don't need a constructor. The only thing I need here is a run method. So def run. Okay, that's all that we need. And just to give it enough time to let some other things start, I'm going to put a time.sleep, and I'll put 0.001. Not much. This is 0.001 of a second. I just want it to sleep long enough for something else to get started. Self.start time. So this is going to be the time that we kicked off all the threads. And then we'll put a loop in here to wait until all of our threads get finished. Okay, you can check to see how many threads are running. Active thread count. When we call that method, when we call this method right here, it'll get the number of threads that are running out there in the thread pool. Okay, so we're going to loop as long as our we're going to stay in this while loop, and we're going to keep looping until all of our threads are finished. So we'll put a little delay in here. Time.sleep. Okay, sleep for half a second. We'll call our Q application, send posted events. Okay, and then when we get down below this while loop, all of our threads will have finished, because this while loop is doing nothing but looping until all of our threads finish. Okay, minus self dot start time. Okay, print. I'm going to copy my format string right here from my other one. This is going in my Watchdog Task here. Okay, looks like my indent's a little bit off right there. Okay, that's better. Okay, so duration, yeah, that looks like that's gonna work. Okay, so we've got that print. So now all we need to do is, before we start our other task up, we'll put this one out there to watch for when these things get done. Okay, so let's create this watchdog task to sit out here and run. Now you remember our method was run threads. Okay, and here's where we created the told Qt how many threads we could run at any given time in the thread pool. And remember, I said most of the time you don't need to put this in there, but it does give you some control if you want to. So let's save an instance, self.obj check done is what I'll call it. We'll create a new instance of that object. And remember, the object that we just created up here was called check done. Okay, so this is what we're creating an instance of. Creating an instance of check done. And let's put it out there on the thread pool. Right here, this is the way we can put it out there on the thread pool. Right here, this code. Let me get it. Send something else out there. Our object name is this. So I'm going to copy that and paste it right there. That's going to put that object out there on the thread pool. So this is our watchdog object right here. This is our watchdog object. It's going to start first. It's going to sit out here and just wait for our threads to finish. And what's it going to do when all the threads have finished and it gets down here? It's going to tell us how long it took for them to run. Okay? So that's our watchdog task that we put out there. So now that we've added that task right here, here's where we created it, and here's where we put it out there to run and started it. Okay, so let's try this again and run our threads, and here we go. It looked like there was something wrong in our code, so let's go up there and see what it didn't like. Check done object has no attribute start time. So let's go back and fix that. So check done object self.start time equals time. It said we didn't have a property called start time. So let's just see, self.start time is right here. Oh, duh. That's where it was blowing. So I had a subtraction there. The subtraction's down here. This is where we're getting the time to begin with. So now that we've got that fixed, let's try it again. Okay, run threads. Remember, it should put this check done thread out there that's just waiting for all our threads to finish. When all of our threads finish, it will print this message saying how long it took to run them all. All 7 tasks finished in 7 seconds. So even though we had 7, 6, 5, 4, 3, 2, 1 as how long each one was going to delay, because we were running them almost simultaneously, it only took 7 seconds to run 7 tasks instead of all the summation of those times like we saw when we clicked that. So we've got just one thing left to implement here, and just to show you that for loop, the for loop that will show us the blocking stuff. We haven't written any code for this button right here. So we're almost done with this video and showing you how the QThreadPool works. Okay, remember, this was our watchdog task, to just sit there and wait for everything to finish. You may or may not need one of these, but this just runs out there in the background watching to see when everything finished up. And it's usually a good idea to have something running where you know when things finish. So let's go back to this and figure out our push button to start counting is called what? Push button count. So that's what we're going to connect up next. self.ui.push button count.clicked.connect self. What do we want to call this? Count method. How's that? So we need to write our code. This is going to be some easy code here for our for loop. Def count method. Okay. So all we're doing here is just doing something to basically run while, so we can see that our threads are not interrupting our event loop. We'll have this loop run 30 times. Okay. This is just so that our event loop can do things while we're tying it up here. We'll have this for loop sleep for 1 second each time through. self.ui.listWidget.add item. We'll put something in that list widget, and we'll say the count is, and we'll concatenate that with the string of the I, convert I to a string. Okay, so that's going to add count is, let's see, I don't need that. Okay. Alright, so self.ui list widget dot repaint. I put this in there because a lot of times you won't see this show up in the list widget unless you repaint it. So some systems you may not have to do this, but Windows and Mac OS, for that to work, I had to do it. And we'll put a process events in here just for good measure, so that this kind of responds to things. So that's all hooked up now. Let's run this. So I'm going to start my threads up with my, well, first let's do this, run no threading, so that you can see what happens when we run this. Remember, this is going to block. We won't be able to run our, well, we won't be able to run our for loop, so until this finishes. So there are those threads running. You can see that I'm clicking that button, but it's not doing anything. Once these threads finish, or not threads, but once all these objects finish, we may get our for loop running, because Qt is pretty good about queuing events up. So we'll see if the for loop starts running after all those finish. They're almost done. Yep. See, it started running, and I clicked that button a whole bunch of times. Okay. So eventually, I don't know how many times I clicked it, but it was a bunch, and it was all queued up. So you can see that there, it finally got all my clicks out of the way, and it was able to, each time I was clicking it, it was resetting the count to 0. So that's why we had all those zeros out there, because the first thing it does at the for loop is starts at 0. So you can see that it's running now, okay? And I've clicked the exit button, and that for loop is actually blocking my event loop from running here. So my only way out was to click that. So now let's start this again, and you'll see, you saw how badly that behaved when I was trying to, I blocked my event loop 2 different ways. I blocked it with those objects running one after the other, and I blocked it with this. Now let's see how much better it works when the threading is going on. So we'll start this up with the threading. So here we're kicking off our threads, and you see I click the start counting, and you see we have both things running at the same time. All the tasks finished, and our count was still going. So we could do multiple things at once. The threads here did not block our dialog's event loop at all. Okay? So the threads were spooling up out there by themselves, and they did not block our event loop here in the dialog at all. So that's how to use the ThreadPool. Remember, the QThreadPool is designed to work with Qt. It's a better choice than using Python threads. Remember, you have to inherit the QRunnable task to make a thread object. Remember also that anytime you're running a thread, you really want to create an object rather than just a function. Because if you create that function, there's no guarantee about your variables. You could have variables getting crossed up if there's more than one of these things running at a time. So by creating a separate instance, a separate class, a separate instance of each of these, we get 7 different objects in this program, and those objects are not touching any of the same variables. Each object has its own thread number, each object has its own delay, each object has its own run method, so they all are independent of each other. That's why the objects work so much better when you're doing threading. We talked about the new iter tools with the zip method that lets us get a different task ID and a different delay each time through the for loop. And lastly, we talked about the Watchdog Tasks that we put out there first to keep track of, to see when all the tasks finished. And we got to see how in here, when we were doing our count method, how this could interrupt the event loop. We also saw that if you run those threads with those objects with no threading, how they wouldn't let us click anything either. So hopefully you can see how implementing threading, if you need to do something in the background, doing this threading stuff right here, where we were creating a new object and then putting it out there on the thread pool to run, that lets you run stuff in the background, and you can run as many as you need out there in the background. So that's the end of this video on using the QThreadPool. There'll be one more video that shows you how to use a QThread object. And the difference between the QThread and the QThreadPool is, I told you when we put these things out there, they're out there on their own. There's no connection really between them and the rest of our program, unless you have something checking to see when they finish, like this Watchdog task. if you use a thread object instead of inheriting QRunnable, if we inherit QObject and put those out there as threads, we can actually send signals from our threads back to our GUI event loop. So it's almost like putting a push button out there in a thread, and the thread can push the button where our main program will know the moment that thread finishes. And it's wild that you can even do that because most of the time when you're using threading and multiprocessing, you have to use a queue or a pipe, and this way that I'm going to show you in the next video, you can create threads out there that can send a signal back to the main GUI event loop. So take care, have a good week, and remember there's one more video after this one before we're done with this module.